So my name is Rich Burgess, and I'm going to talk to you about engineering ethics. And my reason for doing so is to provide some insight into how engineers look at their ethical obligations, and that obviously has global ramifications. Many of the problems we're dealing with today either have their origin in engineering or have their solution in engineering, so that's important to talk about. But beyond that, I think there are some lessons that we can extrapolate from engineering to other domains. And so I want to talk a little bit about that. The first thing I want to do actually, though, is I was thinking about who would be a good engineering exemplar that everyone would be familiar with, and my choices were Tony Stark or Scotty. So I went with Scotty. So I have a short clip that Laura's going to play for us that I thought would be helpful. Oh, I need the slide thing too. The clicker. Yeah. Thank you. Thank you.
No, I'm not signing anything. Now get these bloody things off my ship, Captain.
Is there a problem, Mr. Scott?
Aye, sir. I was just explaining to this gentleman that I can't authorize any weapons on board this ship without knowing what's inside them.
Mr. Scott raises yet another point that leads to the bridge. Captain.
Mr. Scott, I understand your concerns, but we need these torpedoes on board.
Due respect, sir, but photon torpedoes run on fuel. Now, I can't detect the type of fuel that's in the compartments on these torpedoes because it's shielded. Now, I asked for the specifications, but he said... It's classified. It's classified. So I said, no specs, no signature. Captain.
Flight check's complete. Good to go, sir.
Thank you, Mr. Sue.
Yes, sir.
Now, if you'll excuse me, sir.
That's good. Thank you. I can't promise I'll deliver any of this in a Scottish accent. Probably better for that. But I really like that clip because it nicely captures the tension that engineers are sometimes faced with between what they're directed to do by, say, their employer or someone else in authority and what's good for the welfare of the public. In this case, Scotty is, of course, concerned about the welfare of the crew. And so he's faced with this dilemma between listening to his captain and his friend and doing what's best for the enterprise. And I hate to offer up a spoiler alert, but Scotty resigns his position at the end of this as a kind of principled stand against what was being asked. So I thought this would set the stage nicely for this discussion. So let me just real quickly introduce where I work and who I am. I work for the Murdo Center for Engineering Professionalism and National Institute for Engineering Ethics here in the Whitaker College of Engineering at Texas Tech. If you're interested in looking at some of our resources, you're welcome to go to NIEE.org, #shameless promotion. There's a number of resources that we've developed over the years, videos, case studies, things like that. Mainly what I want to focus on for the purposes of this talk are what we do in the realm of education and service and even intervention. So our center offers undergraduate engineering ethics courses. I teach several sections of that every semester. We offer graduate engineering ethics courses, and we also offer ethics courses for practicing licensed engineers. So these are professional development courses. And usually we see people taking these because they either need to keep up with continuing education requirements as a part of their license, or because they've somehow done something wrong, according to their state board, and they're sent to us as a kind of ethics community service and corrective action. Finally, some of the other things that we do that I think are relevant here is we do workshops on ethics, right? So periodically we're asked to come out to major engineering firms or professional organizations and talk about ethics. And so that experience is really what I'm going to be drawing on in terms of my comments, and that is to say, both with my work with academic students as well as practicing engineers in the field. And just real quickly about myself, I only bring this up because I think it helps make a point. I actually have 2 degrees in philosophy, and I am an engineering student currently. That is, I'm working on a PhD in systems and engineering management. So what this means is I'm uniquely qualified to answer the important questions like, does that bridge exist? And if so, what's its epistemic status? But in all seriousness, I do think that this background hopefully demonstrates the connection between philosophy and engineering. That is to say, they don't exist on opposite ends of the spectrum, but rather there's a high degree of overlap, and hopefully some of that will come through. And if nothing else, this will help you understand why and how I'm approaching what I'm up to here. And we philosophers, after all, are interested in why. So, why engineering ethics? Why am I talking about this here? Well, I think there's a couple obvious answers to that. So first of all, engineering failures and disasters, right? We're certainly not wanting for recent examples of engineering failures and disasters. We have the situation with Samsung that's unfolding right now. We have the recent shady manipulations that Volkswagen engaged in. We have issues with GM. I didn't put the Flint water crisis up here, but that certainly rates a mention, the Gulf oil spill, and so on. Additionally, we have in engineering what I've come to call marquee type issues. So issues of data integrity. Is it okay to massage the data? Or, what do we do if we have an obvious conflict of interest? Or what happens if our supervisor is asking us to do something that compromises the safety, health, and welfare of the public? What I want to make sure to convey here, though, is to think of engineering ethics as just the sum total of engineering failures and marquee issues is really to miss a lot of what engineers actually engage. Right, so to be sure, engineers might come across these kinds of issues at some point in their careers. But more often than not, the kinds of challenges engineers are faced with that I think many of us, whether we're in engineering or not, can relate to, are issues of competing goods. And these tend to be very complex problems with some high degree of situational sensitivity. So, engineering ethics then enables us to recognize when we're in such a situation where there's competing goods, and then provides us with some methodology and hopefully tools to engage and solve those complex problems in a way that's ethically permissible. Okay, and here again, complex problems we're not wanting for examples. How do we manage water resources? How do we address global climate change? How do we deal with the impact a technology is going to have and look at whether or not that affects everyone evenly, or are there issues of justice and fairness? So given this complexity, where do engineers go for guidance? Well, one pretty straightforward answer to that is the engineering codes of ethics. Now, when I say it as engineering codes of ethics, that makes it sound like it's fairly monolithic in nature, but actually that's not the case. And so what I want to do here is quickly talk about sources of codes of ethics, highlight the advantages and disadvantages with those sources, and paint a little more of a complex and hopefully a realistic picture. So first of all, companies oftentimes have corporate codes of ethics, right? And the advantages to these is that they apply to all employees. You don't necessarily need to be an engineer to be beholden to the company's code of conduct. And there's certainly a motivational factor here, right? If my job is tied to following the rules that my employer has laid out, then I have a certain self-interested motivation to, in fact, make sure that I follow those rules. But there are some drawbacks or some limitations here. Certainly, they're only applicable to those people working at the company. So if I don't work for that company, I'm not beholden to that set of guidelines. And while I think it can be said that there are companies out there that are genuinely good companies, that have a genuine focus on their clients or even the public writ large or the environment, I think generally speaking, corporate codes of ethics are intended to codify behavior that's good for the company. Okay, so the scope is a little bit narrower on these corporate codes of ethics, or institutional. I mentioned earlier that we do have some engineers that go on to earn a professional engineering license. When they do that, they fall under the authority of a state licensing board, and those state licensing boards have their own codes of ethics. So the advantages here are regional sensitivity. If I'm an engineer in Alaska, then I need to understand snow loads and cold weather, extreme cold weather, and how that affects the structure in order to make sure I design something that's not only going to be helpful, but doesn't kill people, right? So I have to demonstrate some level of technical competence, and that, by extension, allows me to act according to my ethical obligations. Now, if I have a license, that means that I'm able to do certain work that other people aren't able to do, and that's tied into my livelihood. And so if I am following this code of ethics that comes from a state licensing board, then there's, again, this kind of enforceability and motivation to follow those rules. Because if I don't, as I mentioned, engineers can be fined, they can be sent to me, and that's a fate worse than death, or they might even have their license rescinded, or they could be completely excommunicated, if you would. So this is a big deal that has major ramifications for them. On the other hand, as we would, I think, agree, that a quasi-legal code of ethics is sometimes going to focus on sort of establishing the basement level standards of behavior. Okay, and it's not to say this isn't important, of course, but it's something that we need to keep in mind. And roughly 25% of all engineers go on to get a PE license. So there's vast majority of engineers that aren't covered by these codes of ethics. Finally, we have codes of ethics that come from professional societies. These enjoy broader membership. You see PEs and non-PEs as a member of this. You see professionals, you see students that are members of these organizations, so broader membership, and also we see a bigger scope in terms of obligations and aspirations. And that is to say, those codes of ethics tend to be a little bit more ambitious in nature. They focus on prohibitions, what you should not do, but also what you should do and what ideals you should strive for. But here again, there's limitations. Membership is optional. And I think we can rightfully ask with some of these societies whether or not the standards that are codified are relativized to American standards. And I think that's something we need to be mindful of when we're talking about global ethics. So I want to close with a couple takeaways, lessons to learn from this. First of all, looking to the codes of ethics as the ultimate source of justification is problematic. And again, this is true in the context of engineering as well as in other fields. Right? Ultimately, our reason to be ethical is not because it's written down in a code somewhere, but because of the impact that we have on people. And given the disproportionate impact that engineers have on people, on the environment, on society, that's really what is the source of obligation for engineers. Additionally, canons and codes cannot be applied algorithmically. It's not a series of if-then exercises. There's no substitute for careful, critical judgment. When we talk about protecting the safety, health, and welfare of the public, we need to define what we mean by safety. Who do we mean by public? What do we mean by welfare? Which leads me to my third point, the importance of teaching philosophy and including ethics in engineering, science, and other domains. So that kind of philosophical inquiry leads to the careful, critical thinking and conceptual analysis we need to rightfully apply and understand our obligations. And finally, I just want to talk about this exercise that I began of comparing and contrasting codes creates an opportunity for dialogue. We can compare, for example, the American Society of Mechanical Engineers Code of Ethics with other parts of the world, whether in Japan or other countries, and look for similarities as well as differences and move towards a global ethic, whether it's in engineering or elsewise. So thank you for your time, and I look forward to your questions.